Hi again, Ariel. Let's take a look at this one, friend. Here we're going to use the quotient rule, assuming that x cannot equal 0, because if it was, then this whole thing would go to 0, and that's not really what we're after here. So, rainbow pen time. First thing we're going to do, and this is kind of a seemingly unhelpful thing, but because we have a fraction where the numerator and denominator are both square roots, I can rewrite it kind of like this. I could say, well, this whole thing is like one big square root of the fraction 280x to the 10 over 7x. Okay? I'm going to go black. So this seemingly kind of insignificant step is crucial for us, because now what we can really do is we can do some division, right? Now 7 into 28, let's pretend we don't have a calculator, because I don't right now. 7 goes into 28 4 7s, so that's going to be 40 times, right? So let's simplify that. I still have the square root, but this is going to be 40. 280 divided by 7 is 40. We just simplified that. And then we'll do our exponent rules here. So remember, whenever we have two exponents with the same bases and we're dividing, we subtract. So this is going to be x to the 9 right here. So this is really what the quotient rule is. It allows us to work underneath the square root symbol by multiplying, which is the product rule, or in this case dividing, the quotient rule, then take the square root after. So now we're not done yet. What I need to do is I need to factor out the biggest perfect square out of 40. Okay, so remember, the big perfect squares are 1, 4. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, on and on and on, right? So let me change my color. Let's figure this out. Well, a perfect square, that could be 4 times 10, right? And also, the biggest perfect square with our x's, remember that whenever we're talking variables, x squared is a perfect squared, x to the power of 4, x to the power of 6, any even exponent is going to be a perfect square as well. So I can rewrite this, still leaving the root symbol, as 4 times 10 times x to the 8 times x. Okay, so see what I did there? X to the 8 is the biggest perfect square because it's the biggest even exponent I could get without going over 9. And again, remember, this is like an exponent of 1, right? 8 plus 1 gives us 9. So now what we can do is we can start taking these down. The square root of 4 is 2. Now the square root of 10 is an irrational number, so we'll just leave that. The square root of 8 is going to be x to the 4. And an interesting thing, let's consider for a moment, just a little aside here. Remember, whenever we have like x squared and we take the square root of that, we get x, right? So, or x to the 1. Effectively, taking the square root of an even exponent effectively cuts it in half. So taking the square root of x to the 8 gives me x to the 4, because half of 8 is 4. Now this x to the 1 again is not a perfect square, so we'll just leave that all under the root symbol, and this is going to give us 10x. Now keep in mind, what we really could do, and this is being picky, is we could list this as the absolute value of x, because we are not taking the negative of any of this, but that's kind of assumed in my book. So take a look. If you get that wrong, just let me know, especially on a test. I will definitely give you credit if you don't include the absolute value, because I wouldn't. You know what I mean? It's kind of implied here, especially with a square root. So 2x to the 4 root 10x is going to be our simplified answer here. Now again, we could pick values for x and we could blast this into a calculator, but it will never even be remotely close to what the actual answer is. That's why we leave it in this reduced radical form right here. Hope that helps. Let me know if it doesn't.